Welcome back, everyone, and thanks for joining me on my journey into Rust. Today, we really get to start familiarizing ourselves with the syntax and semantics of Rust. We'll also gain some insights into how the language works as we implement our first practical project. So let's get started. Today's video will be dedicated entirely to implementing this guessing game. I've already read through what we'll be doing this chapter and highlighted a number of things that I think are interesting that I'm definitely going to want to point out. And as you can see, we have a lot to get through. But of course, the first thing we need to do is use cargo to create a new guessing game project. We'll type cargo new, then guessing game, and move into the guessing game directory. We're not going to revisit the things that we had before in the previous video, like the cargo.toml file, or really test that the default setup works, because it definitely should. So we'll just move straight into implementing the first version of our guessing game. And right away, we're hit with a new bit of syntax, which is this use syntax right here. And what they say is that when we use standard IO, it brings the IO library into scope. So I think the Python equivalent of this is an import statement. So instead of running from standard import IO, we just use standard IO. And we have those two colons in the middle to separate the two namespaces. Now, much like Python has a set of built-ins that are already available for you in the language, as well as a set of modules that it ships with, the same seems to be true with Rust. So I believe the standard library in Rust is significantly more constrained compared to Python, of course, since it is a significantly newer language. But in Rust, these standard modules are referred to as the prelude, which I think is a pretty sweet name. And we can look at what's defined in the prelude for different versions of Rust. If we click the documentation here, we can see the standard prelude contents, and they also have what's changed between the different versions of Rust, from 2015 all the way up to experimental 2024. So we see here that 2015 and 2018 versions of Rust are largely the same for the prelude. And then in Rust 2021, it also included these new items here. So if something isn't part of the prelude and we want to use it, we either need to import it, or we could actually use it directly, which we'll get into later. So we have a number more changes that we need to implement to bring this in line with what they're expecting right now for our project. So I'll go ahead and do that now. All right, so we see a number of interesting things that have been added to the code now. And the first thing I'm going to start with is here on line 8, where we see let mute guess is equal to string new. So let is how we create a new variable, guess, and mute is telling Rust that we want guess to be a mutable variable, because all variables in Rust, unless otherwise specified with mute, for example, are immutable. And what are we assigning to this guess variable? That's going to be a new string. So we have the string type, which is in the standard prelude, and we're using the new function from string to create a new string. For my Python people, keep in mind that this is a function, which you'll be able to tell the difference between functions and methods of types by the syntax we see here. With the double colons, that's a function. Down here, which we'll get to in a bit, we have the dotted syntax, which means that it's a method of what's returned by standard in here. So all in all, for this line, we're creating a new mutable variable guess and passing in a string to it. Another interesting thing that gives us for Rust compared to Python is that strings can be mutable in Rust, whereas in Python, strings are immutable. Moving down to line 10, we're going to use the IO library, specifically the standard in function within the IO library, which is going to return an instance of a standard in type, which we can see defined on the right here. Now the standard in type has a few methods. We then use that standard in type to call its readLine method, passing in a mutable reference, which is our guess variable. Now this is something I thought was kind of neat, is the distinction between passing in mutable references versus references in general. If we were to get rid of mute here and just pass in reference guess, that would actually just be the reference itself and be telling Rust that this isn't a mutable reference. But since readLine needs to pass values into some variable, we do need to specify that this is a mutable reference guess, which then the text could be read into. Now, there's something interesting about readLine as well, is that not only does it pass the text that we get from standard in into the guess variable, but it also returns a result object itself. And that is actually considered an enumeration. So an enumeration in Rust is a type that can represent multiple states, if you will, or multiple variants, as they're called. So if we look at the definition of result, we see that it can either be an OK or error variance. Something else that's interesting about these is they also implement other methods. And the method that we're interested in is expect here. So expect is going to check the state that it's in. If it's OK, then it really doesn't do much. But if it's in an error state, then it's going to print this message, which I need to put an extra space there. We'll say failed to read line. It'll actually raise that up basically as an exception. So it's kind of neat that we have things that could do double duty here. And considering that this is one of the first examples in the language, I'm guessing that's going to be fairly common. So for this statement, we're using the standard in function from IO, which returns an instance of standard in. We're going to use that instance's read line method, passing in our mutable reference guess, which is then going to store whatever's on standard in to guess. And it's also going to give us a result object. We use that result object's expect to see if it read correctly. And if it didn't, it's going to raise up this exception here. So a lot going on in this single line. And then the very last line is we're using that print line macro and passing in a string that it's going to format. So this is some of the extra magic that I was thinking was going to happen with print line since it's a macro, which made me curious about Rust macros in general. So I did look into this a bit more, which kind of is jumping ahead. And what I've gathered is that Rust macros are a bit similar to other languages that have macros like this. It effectively allows you to generate code at compile time. So what I'm thinking that this is doing is the print line macro. It's reading through the format string that we have here. It sees that we're trying to format in this variable substitution or a local variable guess. So it's likely putting all of that together with the context clues it has at runtime. Now, an alternative way we could have done this is to leave this part of guess blank and then passing guess explicitly here, and that would do the same thing. But I like the formatted string version better. Okay, and that brings us to the end of the initial version of this example wants us to do. So the only thing left to do is to use cargo to run it. So it compiles, it wants us to guess a number, which right now we don't have anything in place to have a random number to check against. So we'll just put in 13. And it says that I guessed 13. Okay, so let's open back up our program. And it looks like in the next section, we're going to be generating a random number. I find it kind of interesting that Rust doesn't actually include a random number functionality in the standard library. But I think conveniently enough for this example is that they do provide it in a crate. So crates are effectively non-first party libraries that we'll add as dependencies to our project, which will then be built into it at runtime. So actually won't be opening this back up right now, and we will in fact be editing our cargo.toml file to add in a new dependency, which is going to be rand equal to 0.8.5. One note that they have here is that it definitely does follow strict semantic versioning rules. Now, even though we specified 0.85 here, Cargo will actually install by default dependencies up to 0.9.0 for this rand library, because the assumption is that anything until a minor version update, which is the second digit here for semantic versioning, would be compatible with all other versions of the same semantic release. So theoretically, everything from 0.8.0 all the way up into the last 0.8 release should be compatible. So the Rust community must really stick by these strict semantic versioning rules. Okay, we'll save that and build it with Cargo. And we see that it's downloading the dependencies for the rand crate and compiles them all together. Now, if it hasn't detected that anything has changed with the dependencies, subsequent builds should, not really do anything additional. But if we edit the main file and change something around a little bit, say this error message here, we'll save that and rebuild. This time it didn't download the dependencies again because those are still fine. It just recompiled our game. So let's clear that out to give ourselves some space and look in our current directory. We see not only our cargo.toml file, but a new cargo.lock file that we didn't have before. And if we look in there, we see the additional packages that have been downloaded. Most of these are dependencies of the rand module that we downloaded, which we can trace through the dependency list. We look down at rand, we see that it needs libc, rand cha-cha, and rand core, which each of those also has some additional dependencies. So we'll recursively install all of those. Now this lock file allows us to ensure that we have a consistent build, locking each of these to specific versions. But we can override this at any time by running cargo update. And if there were any updates to any of these packages, it would install them and then update those references in the cargo lock file as well. Okay, back to our guessing game. And now that we have that rand module, let's go ahead and start using its functionality. So we'll say use rand, and we're going to do double colons, and then RNG. Now this is actually different than the line above, where use standard IO was functionally equivalent to an import. Use rand RNG is actually bringing the RNG trait into scope, which we need that trait available for what we're using with the rand module. Now, not to get too specific, if you're curious what a trait is, before we really dig into that in a later video, like I was, traits are effectively commonly named functions that multiple types or modules can implement in different ways. So while we're using the RNG trait from rand, it would be theoretically possible for some other modules, say, if hypothetically the standard module were to implement RNG, for it to have its own version of that as well. But for now, we just need to know that we're bringing the RNG trait into scope, but we'll actually be using the rand module or rand library to generate the random numbers. So let's do that now. We're going to do that by creating with let a new variable called secret number. And since we didn't say that this is a mutable variable, this will be an immutable variable because we only need to get the secret number once, and it should be constant through the rest of the program. So from the rand library, we're going to use the thread RNG function, which is going to give us a random number generator that we can call genRange on. And we're going to specify a range by saying 1, then 2 periods equal to, and 100. So that's definitely a little bit of a different syntax than we're used to seeing in Python. But 1 and 2 periods here is the starting point of the range, and it's going to go until the number is equal to 100. Another difference here between this range function and what we'd see in Python is that it is inclusive of both the start as well as the endpoints. So we could have numbers 1 or 100 returned from this genRange method. And then the final addition they want is for us to use println again, print out the secret number, just for debug purposes. Okay, so now that we have that written out, let's run it and see what it looks like. Okay, we tell it to guess the number. The secret number this time is apparently 53. So for our guess, we'll again say 13, because of course we're not doing any type of checking here. Now another cool note that I saw here is it tells us we can use cargo doc -- open here to build project specific documentation. So it's going to read through all the different libraries that we've added to our project, and we can go through each of the crates, like the rand crate, and get documentation specifically for that rand crate. So if we go down here and we look at the RNG trait, it looks like we get the trait definition as well as the methods that it provides, including that genRange method. And if we click through that, we also get the definition of that as well, including some examples. So I think this is really neat. And this is definitely something that we need in the Python world. Now, the difficult thing for Python people is we don't really have a standard way to document things, so it'll probably fall through at that part. Anyway, back to our game. The next thing we're going to do now is we're going to implement our comparison part. And to do that, we need to bring something else into scope. This is going to be from the standard library. We're going to be using comp and the ordering type. So we're going to go all the way down to the bottom here and add in something new altogether, which is a match statement. So I'm going to write this out and then we'll go through this. All right, let's look through this. So we have the match statement, which is going to match based on the output of guess.comp, comparing guess to secret number. And notice that we're passing secret number by reference, not by mutable reference, but by an immutable reference, because guess.comp doesn't actually need to change secret number itself. And the output of this comp method is going to be actually an ordering type. So these three next lines are what's known as match arms, and they consist of a comparison expression and then the expression to execute if the comparison matches. And it's going to go from top to bottom here. So the first one to match is what it's going to execute. Now, ordering itself is another enum, meaning that these less, greater, and equal states that it has are variants. Much like we saw with the result before, with its OK and error variants, these are made available for our comparison to match against. So while this might look a bit intimidating at first, it's really not all that difficult, because we're doing exact matching on the left-hand side of this expression. So if our secret number is something like 17, and we guess 54, then guess comparison is going to return an ordering type where greater will match. And in this example, we're going to run into an issue when we try to compile it, which they want us to run into now. So let's spring that trap. Yep, we run cargo build, and we see we have an error here. Error 308, which is mismatched types. So we're actually comparing a string to an integer, because secret number was an integer that was randomly generated. However, guess was a string that we read in from the command line. So the next thing that we need to do is go back into our program. Then we need to add a new line here, creating a new guess variable, which will be of type U32, which I believe is an unsigned 32-bit integer. And what we're going to assign to that is we're going to take guess. We're going to use its trim method, which is going to get rid of any white space, including new line characters. Then we're going to run parse method, and then finally pass in another expect, which with this giant YouTube font size has overridden the line and looks a bit ugly. But let's see what's going on here. So we've already defined guess before up here where we assigned a new string to it. And on this new line that we added, we're assigning something else to guess. This is what Rust calls shadowing, which in my opinion is basically just a fancy way of overriding one variable name with another. So when we shadow this with the new unsigned 32-bit integer, the string that we created before is likely going to fall out of scope and probably be deallocated from memory. Of course, after we complete the operation on the right-hand side of the expression. So on the right-hand side, trim is pretty self-explanatory. But parse, I think, is a bit magical, because Rust is actually inferring the type that it needs to parse the guess into by the left-hand side of this expression. So I believe at compile time, it's updating the information here to basically pass into parse that it needs to convert that string into an unsigned 32-bit integer. And of course, this also has an expect method, which once again, I put a typo into, where if it's unable to parse it correctly, it's going to raise that exception message that we have there. Please type a number. Okay, so we're getting closer to our guessing game being completed. Let's save this and then use cargo to run it again. It compiled correctly. The secret number we need to guess is 85, so let's intentionally go a bit low and tell it 24. We see you guessed 24, and we see that the value is too small. We want to try again. This time the number is 21. We'll guess high this time with 56. We see it's too big. Try one more time. This time we're going to guess correctly with 25, and we see that we win. Awesome. So our match is working correctly, checking the three states that we have there. Of course, it would be inconvenient for our user to have to run our program every time that they want to try to guess a number and getting a different number every time, so they have to get it right the first try. So the next thing that we're going to need to implement is looping. So go back in here, and where we need to start looping is all the way up under where we printed out our secret number. Basically, each time we're going to go through, we're going to prompt the user to input their guess, and then we're going to read that in. So that we're going to define a loop this time is by using the loop keyword here. And then anything between that parenthesis and this parenthesis are going to be looped. Of course, we do need to indent everything above it. So we'll do that now. And now we should have a game loop. So let's save that to our screen and use cargo to run it again. So this time it says secret number is 49. We give it another guess, 23. It's too small. 35. It's too big. Let's go for 49 and we win, but it's still asking us for our guess. That's because we don't have any type of escape condition for our loop. So it's going to loop infinitely or until we get some type of error. Now, while our user could just give some type of bad input to create that error, that's not exactly ideal. So you see there I entered a string test, which gave us our exception condition, and that crashed the program. Not great. So the last two things we're going to do in this video are to add conditions to escape the game loop after getting a correct guess, which we'll do by modifying the right-hand side of this match arm. So instead of just having the print line, the way that this works is we're going to wrap a couple different expressions, each terminated by a semicolon, adding a break statement under equal here. So if the user guesses the correct number, it's going to print you win, and then it's going to break out of its parent loop. And then finally, to add the invalid input handling, we're going to modify the assignment that we have here. Instead of just going straight to guess trim, we're actually going to use another match expression. This time we're going to match on the output of parse, meaning we can delete this really long line here and replace it with some nicely nested brackets. And in here, since parse returns an enum with two states being okay, we'll pass in num. I'll talk about that in just a second. And on the right hand side of that arm, we're going to have num there and then error, put an underscore there, which is likely familiar for the Python people, and then a continue statement. Okay, a few different things going on here. So I didn't guess this initially when I was looking at our first use of match, but match is an expression that also returns the right-hand side of the matched arm. And then on the left-hand side of this, looks like you can do some form of dynamic variable creation. We created a new variable num here and assigned the value that OK stored into it, which we then return on the right-hand side of the match arm. And it's that return, which should again be a U32 integer that is stored into guess. Now, if an error happens, we don't really care because we're going to continue the loop anyway. So we don't need to store that into a variable that we actually care about, which is why we use the underscore convention there. Okay, so I believe at this point, we're good to go. So we'll save that, give ourselves some more room, use cargo to run that again. We get our secret number is equal to 40. Again, we'll try the low condition. We'll try the high condition. We'll try a bad input, which is working correctly. It's saying, please input your guess. So we're not just erroring out, which is great. And then hopefully when we return the correct number, being 40, it should exit the loop and our program. So we win. Now let me fit this all on screen so we can look at it before we go. Although this was a short program, they really packed a lot of new syntax and rules of the Rust language into these few lines, which is pretty impressive. So before I go, to take some time to digest all of this, I do want to show you one final thing, which is a follow-up from the previous video, which we'll say is a small reward for you sticking this long into the video. So in the previous video, we talked about how we have Rust format, right? Well, Cargo also has a format version that it can operate on your entire Cargo project. Additionally, it can also fix issues that it identifies, which is a great thing to add into an alias like this to chain Cargo fix. I'm putting allow dirty in here because I don't want to have to deal with the warning that it gives for things being unstaged in Git, which then goes into Cargo format, the formatter code, and then Cargo check to give a final code check. So if you run FFC here with this alias, it's going to go through the program. And if we look back through it, we see the only significant change that it made was that it reordered our use lines here. And with that, we're at the end of this chapter and the end of this video. Thank you so much for making it this far. And if you have any notes of anything you found interesting or challenging, or have any questions about what was covered in this video, please leave them down in the comments and we'll try to get through them together. The point of this series is for us to learn Rust, so we really want to make sure that everyone's on the same page. And don't be afraid to ask any question that you might have, because while you might think that the question is silly, I can guarantee you that at least one other person has the same question that you do and may be too afraid to ask it. So please ask for them. But as always, thanks for watching.